Good morning, everyone. I'm Matt Westerby, Digital Research Officer at the National Gallery of Art. I'm thrilled to be here this morning and with you all, and to present with my colleague and collaborator, Valeria Federici. We are also part of a team led by Peter Lukart, who is project director for the early history of the Accademia di San Luca and associate dean at the Center for Advanced Study in the Visual Arts. So in what follows, we give our version of minimal computing for maximum interoperability and share on our work to build a digitized collection with IIIF for around 450 notarial document transcriptions, historical maps, and Roman guidebooks for the research project. Now, the concept of minimal computing is not new to the IIIF community or to IIIF itself. In the 2018 annual conference, Mary Nyrop presented on WAX, which is a set of workflows for minimal IIIF websites that are, quote, peripheral to institutional infrastructure. 3 years ago, Matt Jordan and Mark Baggett introduced Canopy on the principles of computational reuse and collections as data. And in 2022, Rupika Risam and Alex Gill offered 4 questions to define minimal computing. What do we need? What do we have? What must we prioritize? And what are we willing to give up? The Canopy, IIIF, and Choir projects that we are presenting today, and the GitHub repositories with image tiles and manifests respond to each of these questions. We needed easy to maintain websites. We had images, metadata, and a commitment to IIIF, and we prioritized sustainability, citability, and interoperability. And in the end, what we gave up, we might have already lost in previous migrations. So there were 2 earlier iterations of the research project online. The first website was a platform designed around TEI XML, launched in 2010, funded by a grant from the Getty Foundation. When the National Gallery moved to a new web platform in 2015, the website was rebuilt to share components with other parts of the National Gallery's website. And to do this, the rich TEI markup was stripped away. So in my view, this was a moment where giving up something later also presented an opportunity to focus on interoperability with IIIF. And in 2016, the site content grew to include hundreds more transcriptions and deep zooming images with IIIF annotations. So faced with a third migration in 2025, we took time to survey the options supported by our digital teams at the National Gallery, including several content management systems. Our scholarly focus of the project, our multilingual requirements, and our desire for sustainability and citability did not always match up. So what we chose to build is a series of static sites suited to various content types that were previously consolidated in a single platform. For transcriptions, historic maps, and guidebooks, we designed around Canopy IIIF, which is what you're seeing here. For scholarly essays, we created 2 volumes of Choir publications. So this is our multi-platform approach, and Valeria will say more on that. Canopy takes the IIIF images, metadata, tags, and annotations in our manifests, and it generates a website around them. Our team then adds interpretive text with Markdown, and we manage all of this with a team of 2, leaning on our front and back-end digital teams for minimal support. We have a timeline on the site, and this timeline is one example of how Canopy IIIF lets us present archival documents by referencing a single manifest and reusing it. Most of the documents published on our site concern property rentals, collections of dues, appraisals of artworks. Others show evidence of decision-making, like the founding of an academy by electing its first leader, or principe. We illustrate this document for historical context in the timeline, adding a brief description and referencing the manifest. When you land on our resources website, the main page calls out 3 types of collections. As we just saw, the timeline, which traces key moments in the early history of the Accademia di San Luca, a research section that republishes 5 short essays in English and Italian on the building buildings that hosted the Accademia, and an About section that describes the history of the project and technical details, which is this page. So here you'll find a documentary history of the Accademia, a digital project history, transcription conventions, tips for citing our project, links for bibliography, and credits to collaborators. And there are 34 names for previous team members since we've been running for 15 years, and it's a feat in itself. As sketched out in this diagram, we position ourselves as researchers and content authors at the top left, and our research users at the right. Our static site, level 0 images and metadata is served as static files with a GitHub repository at relatively minimal cost. After migrating data from our previous platform, our team curated image collections and metadata using Tropy, which is a tool for organizing research photos. Images and our transcriptions were then exported with Tropify, an extension that pre-generates image tiles and creates IIIF manifests. Although not illustrated here, some post-processing was needed after exporting from Tropy to remove a few legacy HTML tags, and we did that with a Python script. We also used a version of Tropify extension that added support for Tropy tags, and we are really grateful to Martin Passos and Bruno Bucalon for supporting that extension. The version number is at the bottom there. So this publication model allows us to migrate across websites easily without locking our project and transcriptions inside an enterprise-level platform. Of course, we have no plans to migrate away from Canopy IIIF, and we are also immensely grateful to Matt Jordan and the IIIF community in general for developing open source tools and teaching us how to use them. So briefly, this graph shows the 6 public GitHub repositories that we created for our multi-platform model. And again, our team of 2 manages these ourselves. Jumping to an example document, this transcription is labeled 1621. And because we selected dates as a significant category for our project, Canopy IIIF builds a site that cross-references dates across all the manifests and displays them as web pages, along with any other facets you choose. So from this example, we enabled Canopy, the feature to show also the IIIF badge at the top right, so there you can view the manifest or copy the URL. Now there's also this view, which is more of an interface-oriented look at the tools that we used to build the site. Leveraging our institution's existing GitHub services allowed us to establish our project with a sustainable set of tools that, again, we steward ourselves. This pipeline from curated images and metadata to Tropy, to the presentation and design of the resources on our Canopy IIIF website gives us the room to grow and to refine. One takeaway from our approach to minimal computing and interoperability is that digital scholars can produce thoughtfully structured, sustainable data sets with open source tools created by the community. Now I'll pass the podium to Valeria.
Thanks, Matt. Hello, everyone. Thank you for being here. So on this part of the talk, I'll describe some more our Canopy IIIF site and how our manifests and other content interlace. I will then focus on an aspect that relates to the theme of sustainability, specifically how we moved from a single platform model to a multi-platform model. So when you arrive to our Canopy site from our landing page on the National Gallery of Art, which is number 1 on this slide, you see a screen with multiple pre-filtered documents. And this is a resources page where you can search using the top bar. You can launch a text-based search to additionally filter the documents that we have pre-filtered. You can also find on the left-hand side an active link that goes back to the Canopy homepage, the one that Matt just described, and on the right there is the opportunity to navigate the additional content of the site through a menu. So there are other ways in which Canopy suggests that there is more to your search results. And it can be useful to look at the tabs on the left-hand side to find out more about textual annotations that refer to the search you supposedly just launched. For instance, I offer, here you can see that if you go to the annotation tabs, you can already see, I was supposed to read this slide, but it's very hard to see from here, and so I invite you to read the bullet points. But to summarize, on the left-hand side, you can see that through the preview of the search results under the annotation tabs, you can see what kind of document type you're looking at. So whether the document type is a notarial document, whether it's a map, or whether it's a guidebook. So to see more of the possibility for searching, I was supposed to have here a different thing. So just to, I want to see, okay. Skip a couple of slides. There was a little bit more to my search results. So let's just say I'll go back to. I switch back to the work. Okay, to the work tab. So switching back to the work tab, you can narrow down the number of items shown by clicking on the filters button that it's always available on the top right of the resources page, and select the facets that you're interested in. And then one thing that you'll notice if you do that is that the search results will update in real time. So one thing that it's important to note here is that the filters are shown based on the number of appearances in the database. So the order is not chronological nor alphabetical. And so it's important to keep this in mind when you're looking for something. So this is what a manifest page of a notarial document looks like. And I also wanted to point out that the site includes maps and guidebooks, as I mentioned before, and the layout of the manifest page is the same for all those items, even though they're different document types. So on the manifest page, you see the manifest on the right-hand side, and you're very familiar with what a IIIF canvas is, etc., so I'm not going to go into details. But on the left-hand side, you see the metadata, and that is what we have entered in Tropy, so is what we assigned to each document. So it's important for us to have the collection where the notarial documents are coming from, and then the other metadata that you might not otherwise find, like notary, for instance. And then you see that there is more. There is the associated names, and there is under the manifest on the right-hand side, there are the annotated words in the document. So there are different, even though we call both annotations, but there are two types of annotations for our notarial documents, and one is the annotations that is basically a transcription verbatim of the notarial documents, and the other one are the annotated words that we highlight in each individual document. So if you scroll down, the document page is very rich, or the map and the guidebooks page as well. And you find key terms, which are all active links, so you can filter down your search results even more by just clicking on one of these key terms on the left-hand side. They're green, and it's what tells you that there are active links. You can also search the transcription, the verbatim transcription, by clicking on that magnifying glass icon even more, and then you find, if you have a manifest with multiple notarial documents pages, you can find individual page with the verbatim transcription side by side. And then if you keep going down, then the Canopy site basically, like, based on the metadata, gives you additional documents that you might be interested in based on the search that you launched. So just a few minutes ago, I mentioned that the different elements on the Canopy site interlace in many ways, and this slide shows basically how. So the journey starts in a place page where the name Flaminio Vacca, who was associated with the Accademia di San Luca, is linked to a filtered search page. From there, you can click on the related document and find out more about Vacca, who is labeled as an associated name by us, meaning his name appears in this inventory shown at the bottom right from 1607. By clicking any active metadata links on this page, you can see other items that share the same metadata as I just mentioned. And at the top of the metadata section, you notice that there is a document there is a label referenced, and which tells you that this manifest is actually also on the timeline page. So this reference is created automatically by Canopy as soon as you embed a manifest in a page. So you don't have to create manually additional links. And you can click that link to then go back to the timeline page. This works for every page that you have created on Canopy. So as soon as you embed a manifest that is present in the repository, that goes into the reference page. So this takes me to the final section of my presentation. I haven't looked at the timer, but I think I'm okay. What you see here is the various elements of the project on our landing page, which is managed in the Drupal. This is the National Gallery landing page, separate from our Canopy site. The newly launched website and overall project was designed to be sustainable, reusable, and to employ minimal resources. The research team has decided to adopt a series of open access options to move away from the single platform model, experimenting with a multi-platform methodological approach that includes, along with the Canopy site, Quire for digital publications, and Zotero for the project's online bibliography that includes more than 900 entries. As mentioned, these interoperable components are open source and free to use with relatively low initial costs. They can be deployed by users who wish to generate their own research from the same source materials. They are also scalable. You can use them for a relatively small project that is managed individually, or you can use them for a more complex project that involves several departments and an existing infrastructure, such as the case of our project. The result is that instead of having a single platform that would have required potentially a high level of customization and therefore probably outsource expertise, the project has been realized entirely in-house. The National Gallery of Art already had a corporate GitHub profile we could rely on, and all the other applications are ready to use, and we basically use them almost out of the box, and you can decide whether to do that or to customize them, or to refine them with a level of customization that is adaptable to your team and the skills available internally. So one aspect that I consider extremely important as a result to the move to a multi-platform model is that if any of these platforms will encounter problems that we know are common in working with digital outlets, such as obsolescences, server failure, similar things, we will have to deal just with that specific component, but the rest of the project will stay on and uncompromised. So why am I stressing this part? This is a project that spans more than a decade. Many elements that were originally considered and added to it, such as the TEI that Matt mentioned, are no longer used. Others have been added over time since the project, as it usually happens, has grown, changed, evolved, and it has been expanded significantly. Even though the migration has been challenging for the team, it gave us the opportunity to rethink the whole project and to have a long-term strategy that is much more in tune with its content and use by scholars and researchers. We no longer rely on the web infrastructure of the museum, and if and when the gallery decides to refresh the website one more time, Accademia site will not be affected. Last, a multi-platform model gave us the opportunity to pick and choose the open source resources that fit our content the best. instead of trying to create something that could fit all the complex and diverse elements that make up the project as of today. Namely, the aforementioned Zotero, Choir, which gave us the opportunity to rethink the scholarly essay editorially and generate new ideas for more publishing possibilities in the future that will use the resources on our Canopy IIIF site, as Choir is compatible with IIIF manifests. It also gave us the opportunity to treat them separately, the essay to treat them separately and adding them to the DOI process by the library at the museum. And this way our authors can have their publications listed, cross-referenced, and tracked. And lastly, the Canopy site that I just illustrated. So launching each component separately gave us the opportunity to work on each of them individually, which was not only necessary due to the size of our team, but also turned out to be more efficient. So in conclusion, I hope I have advocated for a multi-platform model convincingly, and perhaps we will see more projects in the future that will move away from the all-encompassing application model, which along with drawing tremendous resources, at times it condemns the project to be short-lived. Thank you.
If you are standing in the back and you would like a seat, there are plenty of seats on this side of the room. I'm sorry. Okay.
Good morning, everyone. Nice to meet you. My name is Jongwook from Heritage Informatics Lab, the HI Lab, at the Department of Digital Heritage, Korean National University of Heritage. Our university is the only national university dedicated to traditional culture and cultural heritage, including the architecture, archaeology, and the traditional craft, and so on. I can ask one question. How can cultural heritage data become more interoperable, reusable, and meaningful across institutions and disciplines and countries? Our work is situated at the intersection of digital humanities and museum archives studies and information visualization and human computer interaction and knowledge-based system. We are interested in how IIIF can serve not only as an image delivery framework, but also as a shared infrastructure for annotation, interpretation, linked data, and digital heritage service. Our core competence is the knowledge layer behind digital heritage data, ontology design, standard metadata, knowledge graph, linked open data, and AI assist service with verified heritage information. We work across full life cycle of digital heritage, from 3D scanning to metadata refinement and knowledge graph construction and visualization, storytelling, and public access. AKT platform, Agentic Knowledge Twin, is our laboratory testbed for exploring how heritage resources can be connected with ontology and annotation and 3D documentation and AI-assisted interpretation. Through this approach, we are exploring AI collection storytelling and historic building information modeling-based virtual restoration and 4D documentation for intangible heritage transmission, and also 3D natural heritage digitization connected with collection management system in Natural History Museum. HI-Lab is also involved in international collaboration. In Egypt, we have contributed to of building digital heritage center involving 3D digitization and archiving document and platform development and local capacity building. In Saudi Arabia, we are working on a practice-oriented education model for digital heritage and heritage management. And based on this experience, we are also interested in future collaboration around the IIIF-based access and annotation, training, and interoperable heritage data sharing. And finally, I would like to briefly introduce Digital Humanities 2026 conference, which will be held in Daejeon, South Korea. And it will be an excellent opportunity for researchers interested in digital humanities and data standard and visualization and AI and heritage research. Thank you very much, and I will pass to Yeeun.
Hi everyone, my name is Yeeun. I'm the research student studying following the present Jongwook. I'm the first author of this research the project. It is a pleasure to present our work titled Beyond Interoperating, the Integrating IIIF with the 3D Semantics and Generative AI. To deliver this message, I'm preparing my presentation structure into the 6 main points. Based on the applications case study we have been currently conducted, we will demonstrate the methodology of the representing the concept of paradata in the IIIF using 3D semantic and generative AI. Today, the use of the digital technology is growing past across all the cultural heritage sectors, especially in Korea too. But as it is the recently report, the chart on this screen shows, the currently digitalization focuses on heavily on the capturing the visual and spatial forms like 3D scanning and photometricity. This means that we're thinking the most digital heritage management is focused on only one the digital twin. It's like a physical type of the artifacts. With the copies is just a physical form. So it is still hard to find the example that include the heritage core context called as the aura. So in Korea, as the Korean research, we started to think about we have the very similar decision too. Therefore, particularly in the European, they suggested the concept of called as the memory twin. This framework was dealing with the essential value of the heritage. As you can see in the concept of the diagram, this means that going beyond the simple, the physical, the copying to digitization metadata, paradata, and intangible, the community, the value. However, it is still the mostly conceptual level we're thinking. Just for the designing is like a data model. The making, it is hard to find the real application, the cases. That's why we started this research. Based on this technical and the structure, the background, the core, the setting, the core, the purpose of the research is clearly to just present a new dimension of multisensory heritage exploration by combining 3D semantic and generative AI and the IIIF. That just means that we directly map the semantic, the context onto the spatial, the components of the 3D contents. And also the convert into machine readable the state, and the AI can immediately understand and infer. This approach goes beyond the simple, the ensuring data interoperability. By moving away from the traditional keyword based on the researching, we just can show the possibility of the building expanded the heritage reuse cycle, the ecosystem, that maximize user connective engagement in the digital heritage environment. So when we started this project, project, we faced one of the questions, why we needed the metadata, you know? Because the metadata means that we thinking is really similar to provenance attributes but in compared to IIIF, structurally experienced visual materials. Generally, the metadata refers to the characteristic of this object itself. On the other side, the metadata represent the context in which the object was created. So we interpreted this experience that metadata acts as the crucial link that can trace the visual change the record occurring from the perspective of the digital resource. In other words, the documenting the digitization process directly leads to the scientific evaluation and responsibility which enable to functional as independent resource. So in this context, we have conceptually expanded the metadata beyond the merely the documenting, the capturing the context to encompass independent utility of this digital resource. This involves the mapping interpretive elements like how people digitally recovery the part of original object when they have to digitization it. So under this result, we try to find the answer to solve this question. How can we use this metadata model in the IIIF? We checked if we could use idea like the manuscript. I would find this the documents wrote by the Roesja. I know. The which link is the metadata designed with existing IIIF manifesto. To make this successfully, we used the internal linked properties like a CSO or a supplementary with the IIIF presentation, the API to connect the machine readable resource. It's like a linkage between the semantic elements of a metadata with the 3D objects in a multiple layered way. And then we're thinking it can be a foundation to expand this IIIF which focus on re-representative and one point in time to include the creation the process across multiple points in time. So how we can actually apply this is another second questions. So now let's take the closure, the look at the application, the method, focusing on the case study with 2 projects currently being connected by the repertoire. The first project focusing on the physical, the specimen of the nature, the heritage. We aim to show how we can the visualization present the semantic elements like ecology, life cycle, the like original the animals have by connecting the metadata to the 3D object using the 3D framework and web annotations. So, and then we use the fact that the IIIF presentation API introduce unlimited 3D scenes by the connected image and the contents to the campus through the annotations. In other words, we used web annotation within the 3D scenes to show the metadata context. For this, we mapped the relation between the representation, interpretation, the class, and the items created during its changing the process to a specific point or the time on these scenes. By connecting the many points, the metadata can expand it from the hidden text file to the function that users can interact with. Based on the visual context, we built an archival content management system platform that's dealing with the 3D species as independent objects. User can acquire the physical attributes of the 3D species for the research including rotation, magnifications, and measures. And also, they can getting the crucially the platform the links to the observation the class, which provide the geographical locations data. And also, the building the same as the content. Under this situation, the people get integrations is creating an exploratory environment where the user can detect and compare the 3D the changes in the organization's appearance across its life cycle depending on its geographical habitat. This slide is experimental part of our research this year. We are exploring the possibility of the moving beyond simply showing the metadata on the 3D scene to designing a spatial experience. For example, the 3D storytelling, we use a relation between metadata and metadata. For the example, the relationships like inhabits, elevated the scenes of the spatial reality by making the ecological change context three-dimensional. And also the relationship occurs at the time is the visually recreates the casual story of ecological crisis and recovery, such as removing a utility pole. This is demonstrating the potential that 3D semantics can transport a user connective flow into spatial narrative. The next, we will look into another possibility of combining the semantic linked metadata with AI. This project is a case study of transforming a cultural heritage information platform from the keyword-based search to the visual-based explosion environments. The first, to combining the silos, the museum, the domain data with structured data attributes similar to the previous case, like nature, the heritage, applying to by using international metadata standard like CRM, doubling core. At this point, we used the metadata items to extract the changes in the digital visual representation at the contents. Firstly, to combine fragmentally museum domain data. As I mentioned before, at this point we used the metadata to. This slide does mean that how the 3D objects have the linkage with the metadata, the structure. And then the data argumentatively, based on this structure, that was then applied to generative AI using the manifest.json formats. We fine-tuning this data set using the API key, the linkage with the two existing large-scale image generation model, Flux and GPT, and also integrated it with the model that show the higher performance. This enabled us to implement a mixed initiative interface where control dynamically the shift between the system and the user. This is the interface, the prototype, and we wanted to use this image generation, the AI, which used visual similarity directly to the explanation the process itself. With this environment, people can discover their own ill-defined requirements by the visual explanation the process, even though they don't have enough the pre-information like metadata or artifact names. Here, how it worked when the user selected the normal text information like artifact metadata, the visual representation data set of the artifact is sent to our fine-tuning the model, which immediately the visualization it as the virtual artifact image. So the user can access information by the seeing image instead of just reading the text. Finally, the result page, we got the build to provide the expanded recommendation results that go beyond a single artifact to include related artifacts, exhibitions, and distant resource. To achieve this, we developed a hybrid recommendation module that combines the metadata similarity and also the knowledge graph and master similarity. This allows the users to intuitively discover culturally related artifacts and their associations, digital resource, thereby enhancing reusability. Finally, we also currently embarking on the experimenting the challenge. When the user decided on artifact, we also wanted to expand the scope of the model-based recommendation, the research from the image and the related information. As you can see, the slide, we also wanted to offer the creative utilization, the idea for exhibition or education. It's like visually explanation how to use or reuse your informations in our platform. By using the paradata to explain the basic for the specific idea recommendations, we aim to support the user in the critically and creatively reinterpreting the data. We also performed the evaluation for how to the stakeholder like a museum expert to think about our platform. The first case study like the natural heritage platform achieved an overall satisfaction the score the 40 points. Positive response rate for the 3D visualization. The second case study, like the cultural heritage image-based exploration system, showed 93.1 positive response rates with expert rating the simulation highly and non-expert also showing higher satisfaction with efficiency. This evidence, we thinking we can demonstrating that our experiments can support the deep knowledge explorations for the both non-expert and experts. Through this presentation, we are just wanted to show that IIIF extended interoperability beyond simply accessibility into the contextual experience. This will transform the heritage into a living the memory twin that intelligently interact with the user and the people. Thank you for listening to the presentation. Before the cloud, I will share some our information. Especially, we are looking for some the participating that have some the test about the platform I shown in this my presentation, and then give any other the reviews by the interviewing with us. If you any interested in this work, please scan this QR code. This is the web page. Yeah. Thank you for listening. Thank you.
Did you ever get the QR code?
Thank you for being here. I'm really delighted to be participating in a IIIF conference in person. I will present a paper on the digital methods that I developed through my work on the chemistry of Isaac Newton, with particular attention to methods used to reconstitute dispersed manuscripts. And I think this will resonate with a number of the people in the audience. I will be referring to examples from Biblissima and other work developed by our scholars and ambassadors. Although Isaac Newton is best known for contributions to mathematics and physics, he also devoted more than 40 years to the study of alchemy. During this period, he amassed an extensive collection of alchemical manuscripts, copied and translated texts, and conducted laboratory experiments. And his findings form part of a broader investigation that was written in multiple languages, had obscure terminology, but also amounted to about 1 million words. So the example borrows methods from digital experiences and what type of work we can do for text encoding, watermark recognition, and scholarly expertise in the humanities. The material features of these manuscripts present exceptional challenges for scholarship. We have texts written across multiple languages. There's English, Latin, Greek, and Hebrew. So left to right and right to left texts. There are hardly any dates in the manuscripts, and many of these texts are in fragmentary form, dispersed across libraries and collections worldwide due to auction houses and then personal practices for collecting artifacts. Their study then requires close attention not only to textual content, but also to material features such as watermarks, folding practices, and the physical organization of quires and manuscripts. There have been recent advantages in digital infrastructure that make it possible to analyze manuscript images at scale while preserving sensitivity to the material specificity. Through IIIF, manuscripts dispersed across institutional collections can be virtually united, enabling fragments, related witnesses, and material evidence to be studied together within interoperable environments. The examples here actually speak to that because we have both textual testimonies, illustrations with alchemical symbols, but also the value of blank pages that tell us about how the paper was actually manufactured if we look at the horizontal and vertical lines, which are called chain and ley lines for those in conservation. I will be talking about the integration of IIIF served manuscript images, the TI encoding transcriptions, and watermark detection following this. The value of bringing IIIF to this case study resides in producing an electronic edition of the manuscripts, and this project has lived in several institutional homes. It started in the United Kingdom in the late 1990s with the University of Cambridge and Oxford working on the Newton papers, and in the early 2000s at Indiana University, Bloomington, with the chemistry of Isaac Newton that has been variously funded through the National Endowment for the Humanities and the National Science Foundation. The portion of this work has benefited from my funding from the National Science Foundation. The aspect that is immediately available for the community is that we have access to manuscripts, but digitization also reveals how much is lacking both in scholarly breadth and in attention. So the challenge is both material and textual. I'll give you an example of what I mean by that with watermark recognition. And I will divide this up between in-person viewing of a manuscript and then watermark recognition through a repository that we have that's AI operated. This work cannot exist without in-person viewing of manuscripts, especially because watermarks are such faint and difficult features to detect. They can be obscured by writing, drawings, or other marks on paper. In the case of watermarks, we also have the problem that there are catalogs dating when they were made, but we don't know when actually the person acquired the paper or used it. And the two key areas of digital humanities research in this one problem that I'm presenting to you is to develop artificial intelligence and computer vision tools that are capable of identifying and classifying paper watermarks, and then using human expertise for the countermarks. So we have watermarks in banknotes and bills, and this actually happens also in paper, but watermarks actually exist through folding paper, so we have to use human expertise for where the pieces belong together. So for some of these texts, I've actually, you see, they belong to the University of Cambridge and also to Brandeis, but other parts of these alchemical texts actually are in the National Library of Israel. So the watermark is actually a section that has been divided in 4 parts, if that makes any sense. The main repository for the humanities is Charles Briquet and the catalog of the Filigrane. And major watermarks catalogs have been since digitized, but traditional identification methods remain labor intensive and often require specialist expertise. So this one example of the arms of the City of London has several variants, but is actually one of the most common for alchemical manuscripts. Traditional, we have used in-person viewing, and then ask conservators to explore alternative techniques. We have transmitted light photography, raking light photography, but also X-ray imaging and thermography. Infrared transmitted imaging and the testing of different image processing thresholds have actually benefited from methods that have been developed in the Netherlands, the country that is hosting us, and we can learn from their experience to apply that to artificial intelligence tools to identify automatically half of the picture, because we are identifying the watermark, but then the countermark needs to be identified visually by a human reader. So we're looking at watermarks, countermarks, chain lines, and ley lines to annotate discrete regions within IIIF manifests and have reusable data that can be compared across collections that are all IIIF compliant. Thank goodness, because all the collections of Newton papers already are IIIF available. In case you have questions about the Watermark AI database, it is currently unavailable following the suspension of federal funding that supported its maintenance and operation. And it also existed in an Omeka site that might also be discontinued. So I'm bringing this up for a collective site, but also for the fact, yes, Neil, we're seeing it elsewhere, but this can be avoided because we have both the technology and the information that has been put behind a wall. But there is hope of reconstituting some of this research through IIIF tools. The next part where I want to mention some of the IIIF annotation that actually connects very well with what has been discussed this morning is that we use textual and visual cues for integrating our knowledge of the artifact. And in this case, the project had relied on textual encoding that is also required now for accessibility reasons, for the American Disability Act compliance. And at the same time, there are specific cases where this is very, very profitable for researchers, because when we have visual rich text, we can make sense of the alchemical symbols and also the orientation of the text, and see the multilingual expression that is captured here. I want to spend a few moments to say that the manufacturing process and the textual encoding have to be integrated in this type of manuscript studies, because we wouldn't know necessarily the pagination order, but also the relevance of some artifacts. We are talking about items that go on auction houses for hundreds of thousands of dollars. So we also have to be wary that authenticity and forgery are not entirely out of the picture, And looking at shade lines and ley lines often tells a lot of the truth behind an artifact as far as the content goes. In the case of the papers of Isaac Newton, it's particularly significant to look at watermarks and countermarks, and the collection has been so dispersed through sales and acquisitions that it's essential to look at the material evidence. Particularly the example on the left is a case that's from the Huntington Library, and which is a double case of legacy because it came from the Dibner, then Babson College, and eventually the Huntington that maintains temperature and pressure control facilities for these manuscripts. So it's on, loan officially, but it's actually housed there without a due date. And the problem of both these artifacts are that the first example has circular drawings related to alchemy, and the one to the right is actually a zodiac where a natal chart is cast, and then several languages, including Italian, French, and Sanskrit, are captured around these alchemical symbols that are also planetary. The workflow for this project, as I've envisioned it, is that the watermarks and folding patterns, I'm happy to talk more about the folding patterns later for Q&A, help us understand paper structure, establish provenance. There are a number of papers that might actually be forged, and we're not surprised about that. And we can identify manuscript relationships and relative order of writing texts and composing choirs that support ultimately our dating hypothesis. Many manuscripts within the corpus present significant transcription and encoding challenges due to their multilingual content, the ink spilled over, non-standard orthography, abbreviated writing, damage of faded text, and the presence of specialized alchemical symbols and diagrams. The reason also for the textual encoding, I'll go back to this so that we can just dilute the knowledge the way an alchemist would, is actually that a lot of these alchemical symbols are fake, because Newton, who was a very lonely person, did not trust the person sitting next to him or visiting to actually run into his papers. So there might be the occasional symbol for Mercury or Venus, and we know what elements they are, but sometimes there's also inverted commas, my Mercury or our Mercury, and there's no clear identification for that, which is why text encoding has been helpful to mark uncertain readings for symbols and for fake language. Yeah. So let me tell you about the workflow here. I really appreciate getting feedback from my IIIF community. Virtual reunification is the main goal here. So we're following the example of Biblissima reconstitutions and the manuscript curated by Régie, for example. But also machine actionable workflows where I can prioritize the textual or the material aspects so that the page order can take priority for clarity of meaning and coherence. By locating manifests across repositories that are all IIIF compliant, I can work on shared canvases, which allows me to target regions, have annotation layers, and aim for virtual reunification for manuscripts that were dispersed. The integration of the text encoding initiative encoding within IIIF provides a useful environment for scholarly analysis so that text can be linked directly to specific regions of high-resolution manuscript images, enabling users to move seamlessly between transcription and source material. Although the manuscripts are physically dispersed across numerous institutions, IIIF enables virtual reunification through shared standards from image delivery and metadata exchange. So that in a way is almost a form of restitution in the way we do it for reparative work in a museum. When I combine TEI encoding with IIIF image delivery and annotation, the project creates a flexible and interoperable digital edition that supports advanced searching, multilingual analysis, symbol recognition, and future computational research for the community. The framework also ensures that complex manuscript features remain accessible and reusable across repositories and scholarly platforms. In this sense, IIIF is not just about image access, but becomes a research infrastructure, and functioning as an infrastructure allows for computational scholarship in the humanities. I want to conclude by reiterating that specific image regions and IIIF annotations allow to move seamlessly between manuscript images and encoded text. And the workflow in this aspect benefits from moving from IIIF image to region annotation, TEI transcription, enriching the metadata for entities, and then search and analysis. By enabling virtual reunification, IIIF transforms manuscript images for Newton from static digital surrogates into interoperable research objects that can be analyzed across institutional boundaries. Thank you.
Sorry, I'm going to get you the right slide. I'm going to get you there.
Hi everyone, are you up for one more before lunch? Yes? Okay, good, thank you. I have to apologize because I was supposed to do this presentation together with Mick, who is technical, very smart, but unfortunately he could not make it, so this presentation will be a bit less technical and a bit more of a project management approach. So if you have more technical questions, I hope I can answer them. Mick did take the time to prepare this with me, so hopefully I can answer anything, but if not, I will look it up afterwards and get back to you. So don't worry, I will not read this, but in short, before you get lunch, this is what I would like to discuss with you today. So yeah, you can look at that before I get into it. So I'll start with a bit of a background. So I'm from the UBL, which is short for Universiteitsbibliotheek in Leiden, which means Leiden University Libraries. And any Dutch-speaking person will definitely let you know why we do not use that abbreviation in English. We provide at the moment approximately 300,000 manifests, a bit more actually, and we provide them in a repository called Islandora, and it's version 7, I've been told. And the way it's structured is that all our digital objects are accessible in a separate website, digitalcollections.leidenunif.nl. And IIIF is not incorporated within the repository itself, so it is incorporated in the website that we host ourselves. We create the manifest ourselves automatically as well, and we host our own IIIF servers, mainly Rediscache and Cantaloupe. And we also host and provide for all our users our own version of Mirador, and we currently upgraded it to Mirador version 4. But the issue is that starting 1st of January, so at the end of this year, Islandora 7 will no longer be supported, so it will be lost if we don't act. So we acted, and instead of upgrading Islandora, we chose to go to a different repository. So all our digital objects, as we speak, which is one of the reasons why Mick is not here, are migrating, and it's taking us about, I think, a full year only the migrating, and last year we did the preparations. So we chose for Alma Digital, which is a service of the supplier is called Ex Libris, I believe. I'm not sure if anyone's familiar. And there will be some changes. So digital collections will no longer be a separate website, but it will be incorporated within our catalog. So we don't have a different system anymore, starting next year. And well, as I said, we are currently migrating all our items. Alma Digital has an incorporated IIIF feature in the system that they provide in the repository. So they create manifests themselves, which sounds great, but what is the issue? There is obviously an issue, otherwise I wouldn't be here. The issue is that now we have, because we do everything ourselves with IIIF, we are in full control. And it really is the ambition of the UBL to expand, so not just make the manifest and provide them, but incorporate more functionality like annotations. Rama did a really nice presentation yesterday about AI that we want to incorporate as well. But if we completely rely on the new repository, then we have no control ourselves. So we're dependent on what they decide to do, which is against our wishes. And another thing is that the manifest that Alma D, the system that we will use, provides, they are good, but they are different than our current manifests. We will not be in control to adjust them in the future if we may choose to do so. And what's also a thing is that canvas links change when certain changes are made. And I've been told this is because they are based on an identifier called an MMS ID. And if we do major changes on digital objects, then the MMS ID changes as well. So the canvas links will not be persistent. So keeping these things in mind, we also want to obviously not impact our users as much. So what are the solutions to this? And we identified several possible solutions, and one of these, which would be very easy, and just let go of our ambitions, say, okay, great, Ex Libris, you're in charge, we'll just follow along, and we accept our limitations. Another solution is to keep our own system. That would mean we have to develop something that we can integrate our system with Alma D, so that is something we had to build. Then we need to set up new servers and to generate and host all our future manifests. And obviously that would require time and money to both set up and maintain, and especially time is very limited for our specialists. So of course we are going for the more nuanced version, which is typical Dutch, sit in between and don't really go to the extreme. So what we can do is we use the IIIF system Alma D provides. So we let go of our own Cantaloupe and caching, but we keep hosting our own Mirador 4 viewer and develop in that. And of course, that is the solution we went with. So that sounds great. But of course, that's not the end of it, because we stumbled upon the next problem. What do we do with our manifest? Because the thing is, our manifest, if we do it, so the migration now will mean that the URLs of our manifest changes. So if now we have a lot of other organizations using our images on websites or tentoonstellingen, I don't know the word. Exhibitions, thank you, sorry. Stuff like that, and that would mean they would be confronted with broken links. That is not something that we are very happy about, and we really want to solve that. So how can we fix this? Well, we fixed it by making an application. We call it Hero, which hero obviously is a reference to hero, but also hero in Dutch means right here. And what it does, it is an application that provides the newest manifest even if you give it an old URL. So that means not only does it mean that our users will never know the difference, they wouldn't do anything different, they wouldn't be confronted with anything, they will be none the wiser and still can see all our manuscripts at any time. But also, given our ambition to develop things further, it will mean that even in the future, or if we can still make changes without them knowing or having to relocate again. And in, God forbid, we would have to migrate again, it would still help us find this, keep this sustainable. So how does this look like? I have received an architectural plate. So what it does is, I'm sorry, I cannot really, yeah, I'm gonna stand a bit like this because I cannot see it myself otherwise. So what it does is that if you go to one of the URLs, which also always has the IIIF manifest in it, then the endpoint, you automatically go to the endpoint in the backend, so you don't know this, but that is what happens. And then Hero checks where the latest manifest is, and if it's in the new situation, which will, hopefully they will all be in Alma Digital, but otherwise it will retrieve it from the other location, and then it will just serve you the newest one, no matter if you used the old URL. So again, I'm not a technical person, so I hope this makes sense. Well, that was great. We were happy. We had a solution. We had it built. We are currently implementing it. It's almost done. So we were really happy, but of course expectation is not always reality when you are a project manager. So what we expected was that our users only used manifest, but going along and checking with them and talking to them, we realized that there are actually a lot of users that directly specifically use a certain canvas within manifest, which is, I don't think it's the best practice, but it happens anyway. So that is something that we are currently struggling with, like how do we also make sure that people or organizations that use our canvases are not disturbed by our migration. So currently we are developing a persistent identifier to generate a persistent canvas link, and maybe we can use Hero to help us with that as well. So, in conclusion, IIIF, obviously it's an open source, which means there are, and as you can have heard in this conference, it has endless possibilities and it's developing in all directions, which is really great and awesome, but it makes planning and commitment to a certain infrastructure hard, and sometimes, well, you cannot look into the future. So to commit to an infrastructure has its difficulties, and we try to approach this issue with both current and future users in mind, so really looking from the user perspective, how they will not be bothered with everything we are doing here in the background. And therefore we believe that Hero Endpoint ensures both stability and flexibility now and in the future. So we're very happy with that. And I was so happy with that, I edited slide 3 times. And then what's next for us is that we were going live with Hero. It could be really soon. Then obviously we're still migrating from Islandora to Almaty. Then we're going live with Hero, or it can go separate in the same time. Then we want to expand Hero with URLs for canvases or find another solution for that. And after we're done with that, we hope we have the time to develop possibilities to expand our functionality within our Mirador viewer, such as the AI thing that Rama showed yesterday, or also we want to make possible for our users to easily annotate, because we don't provide that service as of now. So that is it.